Welcome to Anything Maths. This video deals with velocity time graph questions. Like the video and why not subscribe to join the Anything Maths family. My advice for you now is to pause the video and try to work out this question, and after that you look at the solution. The question is: a train accelerates from rest at a station A to a velocity of 32 meters per second. It maintains this speed for 72 seconds until it decelerates uniformly to a station B. The total journey time is 112 seconds, and the magnitudes of the acceleration and deceleration are equal. So that information is so important. Okay, it's so important. Find A, the time it takes the train to accelerate from rest to 32 meters per second. From the question, we are given the total time it took the train from station A to station B. We're going to represent that by T, capital T, which is 112 seconds. And out of these 112 seconds, it spent 72 to maintain a velocity of 32 meters per second. So let's represent that also with small t. So 72 seconds. What we're going to do, we're going to find the difference between these two quantities in time that we've been given. So t minus small t will be 112 minus 72, and that will give us 40, I reckon. Now this is the most important point. When we look at the acceleration and deceleration, they have something in common. The initial velocity for acceleration is 0, and the final velocity is 32 meters per second. And the initial velocity for deceleration 32, and the final velocity is 0. Now, we are told in the question that the magnitude of the acceleration and deceleration are the same. So it means that the 40 seconds is evenly distributed on these 2 points. And so if it is evenly distributed and we are dealing with 2 points, all that we have to do is to divide this 40 by 2. So the required time we are looking for will be 40 divided by 2, and we're going to get 20 seconds. So that is the answer for A. And I reckon this is the solution that the examiner had in mind when he or she really came out with the question. But there's another way of solving this. So I just want us to look at that aspect as well from the velocity time graph point by drawing the velocity graph. So let's have a look at that solution as well. We're still on A. Now imagine we don't want to solve it the way I solved it previously. We're going to look at the velocity time graph. So this one will be 0. We label the axis v meters per second, and we have t of x, and this final velocity here will be 32, and we don't know the distance, so we will say t from that point to that point, and that one will be t. We know that from here to here it's 72 seconds. So 72 seconds, and therefore this point will be 72 seconds plus t. And we also know this point will be 112 because we are given. if that place 112, it means we subtract 72t from 112, we're going to get 40 minus t that way. So we're going to use the information given to us. Okay. Now we know the acceleration. Let's define the acceleration to be a1. So a1 from the graph is change in the velocity, which will be 32 minus 0, 32 over t. So that's what we're going to get for the acceleration. Let's also represent a deceleration by a2. And that will be change in velocity, so it's going to be negative 32 all over 40 minus t. Remember, in the question they say the magnitude of the acceleration and deceleration are the same. So what it means is a1 magnitude should be equal to a2 magnitude. And so when you take the magnitude, it's going to be, it implies 32t over t should be equal to 32 over 40t. Now the 32 will cancel, and using any algebra that is really convenient to you, we can say that t is equal to 40 minus t, and therefore 2t is equal to 40, and t is equal to 40 divided by 2, and we're going to get 20 seconds as we got previously. The beauty of using this particular method is now you can answer the B portion. We've answered the first one. You can answer the B portion because the B says sketch the velocity time graph of the train between the. Here, instead of writing t here, you're going to write 20 here. And instead of writing 72 plus t, we add the 20 to it, we're going to get 92. So this also answers the second part of the question. We're going to do the C part of the question. Now, when you look at the graph, it's quite obvious that the graph is a trapezium. So we have two parallel lines. The largest one is 112, and the smaller one here is 72. Okay. You can also divide it into two triangles and a rectangle and solve it that way. But it's not going to help you in the exams because that will not save time. So we know that the area under the velocity time graph is also the distance traveled. So it means that the distance will be half 72 plus 112 times 32. And this will give us 184 times 16. You take your calculator to do 184 times 16, and you will get 2944 meters. So that's the best way to solve it. As I said, you could have divided into the first part triangle, the second rectangle, and the third triangle, and solve it that way. But that is going to waste a lot of time. Let's have a look at the next question. The question is, a train moves along a straight horizontal tracks between two stations A and B. The train starts from rest and moves with acceleration of 0.6 meters per second squared for 40 seconds. The train then moves at a constant speed before decelerating at a rate of 0.4 meters per second square until it reaches B. The total distance between the two stations is 4 kilometers. Sketch a velocity time graph for the motion of the train between A and B. We are told station A, the train moved from rest, so starting from 0, and then move with acceleration for 40 seconds. So it means 40 seconds. From here to there will be 40 seconds. So this is 40 seconds. We don't know the velocity here, so represent it by V. First of all, you have to label your meters per second, and these will be times of seconds. And then it moves at a constant speed for 40 seconds. The train moves at a constant speed before and these accelerate. So we don't know that time, so we represent that time by T1. So it's the time between that portion. So the time over here will be 40 plus T1. And we represent the time is used for deceleration T2. And as a result, the final time it uses will be 40 plus T1 plus T2. And as a result, this represents the answer for A. You are supposed to find the total time taken by the train from A to B. When you look at the graph carefully, we can see that this is a trapezium. In order to find the total distance traveled, we must be able to find what V is and also find what T1 and 2T are. So with the information given, we can find what V is. Shall we? When you look at the acceleration, we are told it's accelerate 0.6 for 40 seconds. So now we can write 0.6 should be equal to the change in velocity, which is V all over 40. And therefore, V will be 40 times 0.6. And what would that give us when you use your calculator? It's 24. So now we know that 24 meters per second. So we know that this V is 40 meters per second. Now we will be able to find the T2 as well, because we know the deceleration. We know that deceleration is the same as negative 0.4 should be equal to negative 24 divided by T2. And therefore T2 will be 24 divided by 0.4. Let's do the sum. It's 60. So we get 60 here. 60 seconds. So we know that T2 is 60 and then V is 24. Those are really, really important. So let me write them here. V is 24, T2 is 60. Okay. Now remember, this is the trapezium. From here to here, it's C1. But the longest side is going to be 100 plus T1 because we know T2 now. So it means this 4 kilometers, we have to change it to meters, which is going to be 4,000, should be equal to half of T1 plus 100 plus T1 times 24. And this work out to be 12. We're going to get 2T1 plus 100. You divide through, you're going to get 4,000. Well, I keep on saying 400. Divided by that should be equal to 2T plus 100. Now, if you work it out, divided by 12, you will get 2T1 should be equal to 1,000 over 3 minus 100. Subtract the 100 from it. You get 700 over 3. Then for T1 will be divided by 2. It's going to be 350 over 3 seconds. And so the total time is going to be 100 plus T1, which is the same as 100. That's 3 over that. Then when you use your calculator, you're going to have 650 over 3 seconds. There's no need to change it into decimals or whatever. You can leave your answer this way. So anytime you're solving this question, take your time. The next question. This question is quite interesting. A particle moves in a straight line with a speed 5u meters per second. D accelerates uniformly for 6 seconds, which reduces its speed to 2u meters per second. It maintained this speed for a further 16 seconds before decelerating uniformly to rest in a further 2 seconds. Sketch the velocity time graph for this information. So the initial velocity this time is not from rest. We are giving a speed. So it means we're going to start somewhere. Let's label our coordinates. So v meters per second. And we have the time t of x. So let me change the color. We're starting from a velocity 5u. So here will be 5u. And it's a decelerate for 6 seconds. So it means it moves down this way for 6 seconds. So this place will be 6. Let's put 0 here. And say it maintains that speed for 16 seconds. So it maintained that speed for 16 seconds. So 16 seconds. When you add 16 to 6 is going to be 22 seconds. And what happens after 16 seconds? Decelerate uniformly to rest for further 2 seconds. So So this place, you add 2 to it, it's going to be 24. And the velocity here will be 2u. So this really, in terms of the first question, we've been able to sketch the velocity time graph. The question is, find an expression for each of the deceleration. So we had the first deceleration, which is from 5u to 2u. Let's represent that one by a1. So a1 will be change in velocity, which will mean 2u minus 5u divided by the time, which is 6. And it's going to be 3u over 6, which then gives you half negative u. So that is that. So there's one way you can write this. You can write a1 is equal to negative half, or you can write deceleration is half u. Okay, so I'm going to stick to the negative. So the negative really shows that it's a deceleration. Let's look at the other one, which is a1, a2. That one will be 0 minus 2u, all divided by 2, because the time between that is 2 seconds. I'm going to give you 2u over 2, which is negative u. So you've been able to express the deceleration in terms of u. Remember, you can also write deceleration is equal to u. The moment you use deceleration, you don't have to use the negative. Okay. If you use acceleration is equal to negative, it also means deceleration. Okay. The next question is to find the total distance. Given the total distance is equal to 220 meters, find the value of u. So looking at the graph, we can see the best way to solve it is to divide it into portions. I'm going to divide it into 2 areas. The first part, I'm going to say this is x1. So it covers up to 0 to 6. And from 6 to 24, I will say is x2. Now, when you look at it carefully, we can see that they are all trapezium. The first x1 is going to be half of 5u plus 2u times 6, which then gives us 7u times 3, and that will give us 21u. The x2 is another trapezium. What is it going to give us? It's going to give a half 16 plus 18 times 2u. 16 plus 8 will be 34, isn't it? Going to be 34 times u, which then gives you 34u. From the question, x1 plus x2 is given by 2, 2, 0. And therefore, we can, it means 21u plus 34u should be equal to 220. Doing the sums, we're going to get 55u should be equal to 220. Divide both sides by 55. 22 over 55. You take your calculator. Divided by 55 is given by, divided by 55, you get 4 seconds. You get 4. Okay, so U is 4. It's not 4 seconds. U is 4. So that solved the question. If you're having problem with it, please read the question carefully. They are not that difficult. So U is 4. And therefore, we can see that the initial velocity, if we've been asked to find the initial velocity, is going to be 5 times 4, which is going to be 20 meters per second. But that's not the question. You're supposed to find what U is. This is another interesting question. A car starts from rest and accelerates at a constant rate to the speed of v meters per second in 6 seconds. The car maintained this speed for 50 seconds before deaccelerating to rest. The magnitude of the deceleration is 1.5 times this magnitude of the acceleration. So this particular information is so important. They show that the time taken for the journey is 60 seconds. Now, we know it took 60 seconds to reach V and maintain for 50 seconds. So we have to know the last seconds is used for the deceleration to rest. So the first acceleration, let's say, is A1. A1 will be changed in velocity. So it's going to be V over 6. Now the deceleration, which is A2, will be negative over T. We don't know that. But remember, we are looking at the magnitude. So in this case, the negative is not going to come into play. And we're given the information that is 1.5 times. So it means that A2 is 1.5 A1. Using this information, we can now say V over T is the same as 5V over 6. The V will cancel and T will be 6 over 1.5. And when you use your calculator, this you can solve it even without a calculator. It gives you 4 seconds. And see the total distance, the total time taken. We know that big T is going to be total. It's going to be 6 seconds plus the 50 seconds plus the 4 seconds, and it's going to 60 seconds as required. So we've been able to prove that or show that. The next question is sketch the velocity time graph for this information. So to sketch the velocity time graph, I've already done. We have V meters per second and we have T of x. You start from rest and you got to a point that we say it's going to be v, so that will be v. And from here to here, we know that this is 6 seconds. Then it maintained 50 seconds. So 50 plus 6 will be 56. And then we calculated the last seconds to be 4. So it's going to be 60. That answers the B question. We're supposed to find the value V. That is what we have to find. Now, looking at the velocity time graph, this is also a trapezium. We know that from this parallel line is 50 seconds, isn't it? And the longest will be 60. And the height will be V. And they're giving the total distance. So we can confidently write that 100,320 is equal to half of 50 plus 60 times V. And this will give you 100 divided by 255 V. Okay? Now divide through by 55, you're going to have V should be this divided by 55. Then take your calculator to find out what the answer will be. Okay, use your calculator well. Make sure they are pressing the values correctly. 24. So that's the value of V. When you are using the calculator, make sure you press the right numbers. On the examination condition, you can press the wrong numbers. So that's the value of V. After all, solving questions on the velocity time graph, as you've seen, is not that difficult. It's a matter of practice. Tell me in the comment section the topics you want me to really treat in applied mathematics in A level, especially AX level. So this brings an end to the video. Like the video and subscribe to the channel and join the Anything Man's family.